and welcome to this tutorial on using the method of joints to solve trusses. The method of joints is a really effective way of solving trusses, and once we understand the procedure, it'll become really simple. So let's have a look at the procedure first, and then let's solve a simple truss together. The first thing we want to do is we want to check if our truss is determinate. If it's determinate, we can solve it using static equilibrium methods like the method of joints. If it's indeterminate, however, we might need to use more sophisticated methods, but that is a topic for another day. The second thing we'll do, if we can, is determine the reactions at the supports. After that, we're going to assume that all the members are in tension. Now this matches up with the sign convention that we'll use here. Tension is positive, compression is negative. So if we assume that everything is positive, or assume that everything is in tension, then if something comes out positive, it is in tension, and if something comes out negative, it's in compression, in line with our sign convention. We'll then disconnect the joints from the members and draw a free body diagram for each joint. We'll then choose a joint with only two unknown forces, and that is because when we look at the free body diagram of a joint, there are only concurrent forces, meaning that we only have two equations of equilibrium. Sum of forces in x, for example, and sum of forces in y, or sum of forces in two perpendicular directions. Since we only have two equations, we can only solve two unknowns. We'll find the forces in the member and work our way from joint to joint using the criterion of only two unknown forces in the new joint to solve. And we'll write and solve the equations of equilibrium for each joint. So now that the method is clear, let's move on to solving something together. Let's start off by looking at this simple truss. This truss has three members and it has three joints, numbered here 1, 2, 3. It has a roller support at 1, a pin support at 2, and 10 kilonewtons in the horizontal direction at joint 3. Before I do anything, I want to create a free body diagram, and that means replacing the supports that are drawn with the reaction forces in the supports. So let's start off by deleting this roller and putting a vertical force in its place, which I'm going to call V1 because it's at joint 1. I am going to take off this pin support, and in its place I am going to put a vertical reaction V2 and a horizontal reaction H2. So horizontal at joint 2. Now that I've got my free body diagram, I can move on and do the first thing on my list. I'm going to check if this truss is determinate. So to do that, I need to figure out what the unknowns are in this truss and what are the knowns. Starting off with the unknowns, what I don't know is I don't know the reaction forces, right? So I have three of those. So I don't know the reaction forces. I also don't know the forces in the members. So that is three members, right? So three forces in the members. So that means I have a total here of 6 unknowns. What do I know though? I know that in any truss at each joint, I can write two equations of equilibrium. So that means that my knowns are always going to be 2 times the number of joints. In our case here, we have 2 times 3, and that is 6. These two numbers are the same, so the number of knowns matches the number of unknowns, meaning I can solve this truss using static equations of equilibrium. So this truss is determinate. So the second thing that I want to do, if I can, is find the reactions. In this case, I have 3 unknown reactions, and I know that in 2D, I have 3 equations of equilibrium. That means the number of reactions I need to find equals the number of equations, and I can find the reactions. So let's do that next. Now, before I find the reactions, I want to define the sign convention that I'm going to use. So what are my positive directions for defining this? So this is my positive x, this is my positive y, and this counterclockwise moment is my positive moment. And I'm going to start off by looking at the sum of forces in the x direction. So if I look here, I've got H2, that is in the positive direction, and then at joint 3, I've got 10, but in the negative direction, so minus 10 equals 0, and therefore H2 equals 10 kilonewtons. And I'm just going to highlight that so it's easier for me to find later. Moving on, I can do some forces in the y direction, but in the y direction I have two unknown forces, so I won't be able to solve them from that one equation. So I'm going to look at the sum of moments around joint 1, okay? And this is my positive direction. So around joint 1, V1 passes through, H2 passes through that joint, so I'm only left with V2 and the 10 kilonewtons contributing to moment. So V2 contributes a counterclockwise or positive moment, and the lever arm is 4 meters, and the 10 also contributes a positive moment with a lever arm of 4. And therefore, if I solve this equation, I find that V2 equals minus 10 kilonewtons. And I'm just going to highlight that as well. And now that I've found that, I can move to the sum of forces in Y, this being my positive direction. I've got V1 plus V2 equals 0. That means that V1 equals minus V2, so that is minus 10, and therefore V1 equals plus 10 kilonewtons. And I can highlight that as well. Before I start solving my truss using the method of joints, I might just want to check that my reactions are correct. So let's do a check here, and I'm going to check by doing the sum of moments around joint 2, the joint that I didn't do. So here I've got V2 and H2 passing through the joint. I've only got V1 and the 10 contributing. So let's see. V1 contributes a negative moment, right? Because it contributes a clockwise moment. So minus V1 times 4. And the 10 contributes a positive moment. So plus 10 times 4. And I can see from here that V1 comes out as plus 10 kilonewtons. And that matches what we just found. So that check has worked out, and I can continue now to the method of joints. Now, before I continue to the method of joints, what I want to do is I want to draw the reaction forces back into my truss in their correct directions. So let's do that first. So I can see here that H2 came out as positive 10. So I can take that H2 and replace it with 10. V2 came out as negative 10. So that means that the direction that we assumed for V2 was incorrect, and V2 actually goes in this direction and is 10. And V1 came out as positive 10, meaning that there is 10 kilonewtons going up here. And now that we have the reactions, we can solve the truss. So let's get to it. So before we start to actually solve the truss, I just want to look at what the method of joints entails. Essentially, if you look here, you can see that I have assumed that each of these 3 bars is in tension, and therefore the forces are pulling them, making them longer, and I've put the corresponding forces at the joints. So you can see when the member is in tension, the forces are pulling out of the joint. Okay. The next step is really to look at these joints. So I'm going to ignore the members themselves, and I'm just going to be looking at these free body diagrams for each of the 3 joints. Now I know that I can only solve a joint with 2 unknown forces. Looking at these joints here, each of these really only have 2 unknown forces. So for this exercise, I can start solving from whichever joint I want. Okay, let's begin. So I can start, as we mentioned, from any joint. I am going to pick joint 2 to start off with. And I'm just going to draw that free body diagram. I've got this internal force here, F2, 3. I've got this internal force here, F1, 2, both in tension. And then I've got both of these reactions that I found earlier. I'm going to start off by doing sum of forces in the x direction, with this being my positive direction. And I've got 10 already going in that positive direction, and I can see that I've got minus F1, 2 going in the negative x direction. And those are the only two things that I have in x, so that equals 0, and F1, 2 equals 10 kilonewtons. Now, it's good practice to highlight each thing as you find it. It'll save you having to look for it later. Sum of forces in the y direction now, with this being the positive direction, and here I've got minus 10 because that 10 is going in the negative y direction, plus F2, 3 equals 0. So here I've got F2, 3 equals 10 kilonewtons. Let's now move on to joint 1. Joint 1, let me draw my free body diagram. So here I've got this force of F1, 2 in tension, I've got this force of F1, 3 in tension, and I've also got this reaction force of 10 going up. I'm going to start off by solving the sum of forces in the y direction here. So sum of forces in the y direction, with this being my positive direction, and here I can see, because it's 4 meters on 4 meters, 45 degrees. So I've got a component of F13, F13 sine 45 in the positive y direction, plus 10, also positive y, equals 0. So F13 equals minus 10 over sine 45, and that works out as minus 10 square root of 2 kilonewtons. So you can see here already that I have found 3 members. I was only needing to find 3 members, and therefore I've found everything that I need to in the truss. I can also see from the signs that I've got 2 members in tension, F12 and F23, and I've got 1 member in compression, F13. But the good thing about trusses is that we can always check our results. So let's start off by doing the equation here for the sum of forces in the x direction, with this being our positive, to check our results. So here I have F12 in the positive x plus a component of F13, so F13, this time it's cos 45 equals 0. So F12 is going to be minus F13 cos 45. So that is minus 10 square root of 2 times cos 45. And that is plus 10 kilonewtons. Okay, so let's just highlight that in a slightly different colour. And we can check. F12 here in our check came out as plus 10 kilonewtons. It comes out in our original calculations as 10 kilonewtons, and therefore it seems like we've solved our truss correctly. We can go on to do joint 3 as a complete check, but before we move on to complete our check at joint 3, what I'm going to do is I'm going to write on the truss the members that I found. So I'm going to do that in a different colour. And we found here that 1, 2 is 10, so that means plus 10 here. We found that 2, 3 is also plus 10, so I've got another plus 10 here. And we found that the diagonal 1, 2 is minus 10 square root of 2. So we found all the members in the truss, but we can do an additional check at joint 3. Before we conclude this exercise, let's just look at joint 3 as a last check. Joint 3, let's draw the free body diagram. So we had a force here, F2, 3. We had a force here, F1, 3. We had this external load of 10 kilonewtons, And we also know that the angle here is 45 degrees. All right, let's start off by checking the sum of forces in the x direction, with this being my positive sign convention. So I've got minus 10 from the external load, and I've also got minus a component of F13, okay, and that is F13 sine 45. So we have here minus 10 minus F13, we can see, we said that that was minus 10 square root of 2 times sine 45, which is 0, and we get here minus 10 plus 10 equals 0, and that is correct. So we know that we've solved this correctly. Let's do an additional check for the sum of forces in the y direction, with this being our positive direction. So here we've got minus F23 and also minus this component of F13, in this case F13 cos 45 equals 0. So minus 23 is minus 10, and minus 13 is minus 10 square root of 2 times cos 45, 0. So that is minus 10, and this works out as plus 10 again, and that is indeed 0. So once again, we've completed another check. So now, not only have we found all the members in the truss, we've also checked them, and we can with confidence say that we have solved this truss using the method of joints. Thank you very much for joining me solving this truss, and I hope to see you soon to solve some more structures. Bye for now.